Hello viewers, you're welcome to my first live stream on YouTube. I know this is impromptu, I never give any notification on this live stream, but no problem. If you eventually come up on this video, tell me if you love the live stream and if you want me to continue on live stream. But today is an impromptu live stream, so I want to talk about inequalities. There's some things I see in inequalities, a lot of people are getting it wrong. I want to correct that here. So let us go into inequalities right now. Now, the question I want us to start with is this. How do we solve this problem? 6 upon x is greater than or equal to 2. How do we solve this problem? Okay, now usually most people will always want to multiply both sides by x, and multiply here by x, and this x cancel this x. You have 6 greater than or equal to 2x. And now they divide both sides by 2, and we have x is 3 is greater than or equal to x, or x is less than or equal to 3. This is part of the answer, but this is not the whole answer to this problem. So therefore, this answer is wrong. So in this video lesson, I'm going to show you how to solve this problem with the right steps and method to inequality. So let me clean these guys up. Now, let's start with this explanation. If I have a problem like this, if I have maybe x upon maybe minus 3, permit me to put minus 3 in the denominator, okay? Then plus 2 is greater than 5, okay? Now, usually when you have this kind of problem, because you want to get rid of the fraction, this 3 is negative, you want to multiply everybody by negative 3, right? So that you get rid of this fraction, isn't it? Now you are multiplying everybody by a negative number. Remember, the inequality will alternate when you multiply everybody by a negative number. So you have negative 3 multiplying x over negative 3, then plus negative 3 multiplying negative 3 multiplying these 2. Then the greater than will turn to less than, because we're multiplying both sides by a negative number. Here will be negative 3 multiplying 5. Now you are aware of changing this greater than to less than because you know you're multiplying both sides by a negative number. The question we just finished solving was x. We multiply both sides by x. We don't really know if x is positive or negative. Okay? That is why we don't need to multiply both sides by x in an inequality, because you cannot tell if the x is positive or negative. So, but here it is clear that the minus 3 is negative, so we can just multiply everybody by negative 3 and thus change the inequality. And here we cancel out, so we have x minus 6 is less than minus 15. And take these guys to this side, you have x is less than minus 15 plus 6. And that will give us x is less than minus 9. This is correct, because you already know that when you multiply both sides by a negative number, the inequality will change. Now, but when you have a variable in the denominator, let's say x plus 2, please you do not multiply everybody by x plus 2, because you're not sure what this quantity is, whether it is negative or positive. So let me show you how to solve problems that has to do with inequality with variable in the denominator. I'll use the sign check method to solve this problem. Alright, let's go back to the question we just finished talking about. We have x 6 upon x is greater than or equal to 2, right? And I said you do not multiply both sides by x because you're not sure if x is positive or negative. So you do not multiply both sides by x. Rather, see what we're going to do using the sign check. We'll take this mark inside, so we have 6 upon x is minus 2 is greater than or equal to what? 0, right? And now you can simplify this whole fraction, right? This is over 1. You use the butterfly style. 6 times 1 is 6 minus x times 2 is 2x. X times 1 is x. We'll simplify this fraction, right? Greater than or equal to 0. Now here comes the sign check. We put up a number line like this that depends on x, okay? So we want to get the max of this number line. So I will equate this one to 0. If I equate 6 minus 2x to 0, I will get that 6 is equal to 2x and divide both sides by 2. So x is equal to 3. So I've gotten one of the numbers, I've gotten one of the numbers to be 3. So let's say here is 3. Then if I equate this one to 0, I'll get x is equal to 0. So the other line is x is equal to 0. But remember, we're not going to take x to be 0. We're not going to make x to be 0, because when we make x to be 0, this inequality will be undefined. So I'll leave this 0 open. You understand? And because 3, this numerator here, and we're having greater than or equal to, so 3 can be inclusive. So I'm going to include this 3, and I will shade this 3 like this. I don't know if you get this point. Okay, here x cannot be 0. If x is 0, everything becomes undefined. It destroys the system. So that's why we cannot make 0 part of the solution, right? But here, x can be 0, you know, it doesn't really change anything when x is 0 here. So that's why we include 3, because we have greater than or equal to right here. Now we do the sign check. What are the numbers you can find here? You can find -1 here. So if I plug -1 into this inequality, what will I get? I will get 6 minus 2 minus 1 over -1. Minus 2 minus 1 will give me 6 plus 2 over -1. And everything will give me negative. So here it will be negative. I'm not interested in the result, I'm interested in the sign of the result. So when I plug, what is the number I can find here? I can find 1 between 0 and 3. I can find 1. So when I plug 1 here, I have 6 minus 2. Then over 1. 6 minus 2 over 1 will still give me a positive number. So here will be positive, and automatically here also will be negative. So you can pick up numbers and try to get a negative result here. So that we're done with the sign rule. Now you want to ask yourself, what are they interested? What do they want us to choose? They want us to choose the positive part, because when you see greater than or equal to 0, it means positivity. So they are interested in the positive part. So we're going to pick this section. We're going to pick 0 less than x less than or equal to 3. So this is the solution to this inequality. 0 less than or equal to x less than or equal to 3. That is the solution, right? Yeah. So you can also test for it. You know, the last one we saw where we got x is less than or equal to 3. If you plug in -4 into this inequality, or -1, it will fail. So that's why -3 is not alone the solution. The solution is bounded between 0 and 3. So anything outside this or outside this will not satisfy the inequality. Okay? So this is how, and this is where I will stop. So you can take this as an assignment. 2 over x minus 3 is greater than or equal to 1. You can go try this one, put your answer in the comment section, and I will see you in the next video tutorial. So if you want a live stream, let me know in the comment section, and I will schedule appointment on live stream. Bye bye.